For question 3, this is a big word problem. We're going to have to draw a picture to understand what's going on. So we've got an International Space Station that travels at a speed of 27,600 kilometers an hour in a circular orbit at an altitude of 400 kilometers, and the radius of the Earth is 6,400 kilometers. So to start off, we've got a lot of information. So we sort of read the question, hold that information, read part A, visualize a line segment joining the space station to the center of the Earth to the nearest tenth of a radian. What angle will it have rotated after 40 minutes? So we're going to draw our Earth here. Add some North America, South America in here. Oh, there we go. Add some islands, Greenland right there, perfect. Get some of Europe going over here. There's the boot for Italy and Africa. Okay, and Australia over there, perfect. A little bit of okay, imagine that as the Earth. And there's the center of our Earth. We know that our radius of our Earth is 6,400. And then we have a space station another 400 above. So here's our space station with these fancy wings, things that I have. Perfect. In 40 minutes, so this space station is traveling in a circular orbit around the Earth. And in 40 minutes, it is going to have traveled a certain distance. So let's say it gets to there. This is not necessarily to scale. How do I know how far it's gone in 40 minutes? Because the question says, find that angle in radians. If it travels 27,600 kilometers in an hour, how far will it go in 40 minutes? How would I figure that out? So I know that it goes 27,600 kilometers in an hour. How do we figure out how far it goes in 40 minutes? Will it be more or less than 27,600 as an estimate? It should be less, because it's less than an hour. We'll have to use that same idea of proportions that we created our arc length and area of a sector formula. We are going this percentage of the hour, 40 out of 60, and if you multiply that by 27,600, what do you get? 18,400? Does someone have a calculator? Is that right? Okay. So we know that this distance along here is 18,400 kilometers. We want to find theta. Looking at our picture, what do we all have? We have an arc length of a circle. We have the radius of that circle. And we want to find the angle. So if we use our arc length formula in radians, our arc length formula was theta r. We know that the arc length is 18,400. We want to find theta. We know the radius of that circle was 6,400 plus 400, or 6,800. We could divide both sides by 6,800. And we get 2.7 radians. Did it say to the nearest tenth or nearest hundredth? To the nearest tenth. will often get arc length application problems, word problems that deal with arc length. So this was one where, again, there was a lot of information given. Drawing a diagram to see what was the information that was given to determine what do we want to find helps us calculate and helps us see this is an arc length question. And because everything is in radians, we would use our radians formula for arc length. We know our arc length, we knew our radius, so we could figure out our angle, and our angle was 2.7 radians. I'm not going to do B right now. B requires you to use the cosine law from grade 11. So if you want to try it on your own, you can, but I won't do it. I think I might have some videos online. If you want to go back to a previous year, you could probably find it. But in interest of time right now, we're just going to do 3A, and the questions for practice are 8 and 9.